Today we're going to be talking about rational numbers. Our essential question is going to be how can you use a number line to order rational numbers? And our goals for today are to understand that a rational number is an integer divided by an integer and to convert rational numbers to decimals. We're also going to be working on converting decimals back into fractions. So let's go ahead and get started for today. The meaning of a word, rational. The word rational comes from the word ratio. Recall that you can write a ratio using fraction notation. If you sleep for 8 hours in a day, then the ratio of your sleeping time to the total hours in a day can be written as 8 hours slept to 24 hours total. Now, when we can write it as a ratio or as a fraction of integers, we can know that it is a rational number. So a rational number is a number that can be written as the ratio of two integers, or a fraction with two integers, an integer in the numerator and an integer in the denominator. So since we have 2 and we can write 2 as a ratio or as a fraction involving integers, we can consider it a rational number. Because -3 can be written as a fraction, -3 over 1, we can consider it a rational number. Since 1 or -1/2 can be written as -1 over 2, it's a ratio of two integers, a fraction we can consider a rational number. And since we can write 0.25 as a fraction, which is equal to 1/4, we can then say that it is also going to be a rational number. What this means is we now have another group of numbers, the rational numbers. A rational number is a number that can be written as a over b, where a and b are integers and b does not equal 0. The reason b cannot equal 0 is we have a divided by b, and we can't divide by b or we can't divide by 0 because that would give us an undefined answer. So as we look at this, we need to make sure that any numbers that we plug into a and b are integers and that b does not equal 0. But as long as we have that set up where we can have a fraction right here between two integers and b is not equal to 0, we know it can be a rational number. Now, this kind of looks like the graphic we had in our first day of notes where we have our whole numbers in the center, and we know that all of our integers are going to be on the outside of that, which means every whole number is an integer, but not every integer is a whole number. Okay. Similarly, every integer is going to be a rational number, but not every rational number is going to be an integer. Okay. So as we look at this, we can say all whole numbers are integers, all integers are rational numbers. The difference between the whole numbers and the integers are going to include the negative numbers. And the difference between the integers and the rational numbers is the rational numbers are going to start including fractions or start including those ratios of integers, so that makes them rational numbers. Because you can divide any integer by any non-zero integer, you can use long division to write fractions and mixed numbers as decimals. These decimals are also rational numbers and will either terminate or repeat. So if we want to know if a decimal is a rational number, we have to look for these two conditions. Either it is going to be a terminating decimal, which means it's going to come to an end. It's going to end at that 5 or at this 5 or at that 5 or some other number, but it's going to come to a stop. So it's going to be 0.25 stop, 0.625 stop. It's going to come to an end. And if it comes to an end, we can write it as a fraction. And since we can write it as a fraction, it is going to be a rational number. Now, a repeating decimal is a decimal that has a pattern that repeats. So we can say 0.333 and it's going to continue that pattern on and on and on. It can be written as a fraction. So because it repeats and can be written as a fraction, we can then say it is going to be a rational number. Similarly, if we have the repetition of 0.151515, since the repetition is that 15, we can write that as a fraction, and then we can make sure that that is a rational number. So with this, we're going to use our bar notation to show which digits are repeating. So since this we have our repeating 3, we're just going to put that bar over the 3, and over here, since our 15 is repeating, we can write our bar over the 15, and we wouldn't have to then write out all of these other numbers. Okay, for example number 1, we're going to be writing rational numbers as decimals. So our goal here is to write -2 and 1/4 as a decimal. So the first thing that we're going to do is we are going to take this 2 and we're going to set it aside. We're not going to work with it right now. We're just going to remember that it is over there. And we're going to focus in on this 1/4. Okay. Now, when we're looking at this 1/4, we need to remember that when we have a number over another number, that's also a division sign. Because if I had 63 over 9, we could do 63 divided by 9, and we would know that is 7. Well, we're going to do the same thing here, but with this 1 and 4. So what we're going to do is we're going to take this 2, we're going to set it off to the side, so we have this -2 over here. We're looking at this 1/4, and we're going to take 1 and divide it by 4. So we're going to put 1 right here, we're going to draw our box, and we're going to put a 4 right here. Now 4 does not go evenly into 1, so we have to add our decimal place, Now we can put a 0 right here. Now we can say 4 does go into 10, and it's going to go into 10 2 different times. So we're going to say that's going to be 8, because 2 times 4 is 8. So we're going to subtract, and we're going to have 10 minus 8 is going to be 2. Now we're going to bring down our next 0, making this 20, and 4 does go into 20. It's going to go in 5 times, so 5 times by 4 is going to be 20. And 20 minus 20 is 0, meaning we've gotten to the end of our division here. Now, as we look at this, we have our 0.25. Now, this is where we need to remember our 2 that we set over here, because our answer is not 0.25. Our answer is going to be -2.25. And that's how we're going to write that as a decimal. Now, as we look at 5/11ths, we're going to do the same thing. We're going to take our 5 and we're going to divide it by 11. So inside of our box, we're going to put our 5, and outside of our box, we're going to put 11. So 11 does not go into 5 evenly, so we're going to put our decimal on bottom and on top, and we're going to add that 0. 11 does go into 50. It goes in 4 times, so we can say 4 times by 11 is going to be 44. We're going to subtract here. 50 minus 44 is going to be 6. Now we're going to add our next 0 and bring that down. It's going to make 60. 11 goes into 65 times, so we're going to say that this is going to now be 55, and we're going to subtract, and this is going to leave us 5. So we're going to bring another 0 down, and as we look at this, we're going to see 50. Now, when we did this the first time, we need to see right here that the first time we had a 50 show up was right here. And the next time we have a 50 show up, we need to recognize that this is going to be a repetition in our division. If we keep going, it's going to keep ending up with 0.454545. So as soon as we recognize that we've gotten back to a 50, we need to say, okay, I'm done. So I'm going to say 0.45, and now I can put the bar over the top of that, and my answer is going to be 0.45 with repetition. So we're going to keep working with some of these. So again, the first thing that we are going to do is we're going to take this 4 and we're going to set it to the side. We're going to say I'm going to leave this 4 over here, and I'm just going to focus on this 3/16. And again, we're going to do our division. So we're going to say 3 divided by 16. So 16 doesn't go into 3, so we need to add our decimal place on bottom and up on top. Add that 0. 16 does go into 30. It goes in 1 time. So 1 times by 16 is 16. We're going to subtract. 30 minus 16 is going to be 14. Add another 0 and bring that down. So now we're trying to figure out how many times does 16 go into 140. So we could try this, and let's go ahead and try the number 8. So 8 times by 6 is going to be 48. So I'll go ahead and do that and add a little tiny 4 right here. 8 times by 1 is going to be 8, plus 4 is going to be 12. So I'm going to put a 12 right here. So I'm going to subtract this, and I see 0 minus 8. So I'm going to put a 3 here, 10 here, and we go 10 minus 8 is going to be 2. 3 minus 2 is going to be 1, and because this number right here, 12, is going to be smaller than 16, that was the right number to use right here. So I'm not done yet. I need to add another 0 and bring that down. So I'm at 120. Well, since 16 times 8 was 128, let's go ahead and try 7. So 7 times by 6 is going to be 42. Add the 2. Again, I have a little tiny 4 right here. 7 times by 1 is going to be 7 plus 4 is 11. So minus this right here, 120 minus 112 is going to give me 8. So I'm going to add another 0 and bring this down right here, and I'm going to add that 0 right there. So I need to know how many times does 16 go into 80. So let's go ahead and try 5. 5 times by 6 is 30. Put a 0 down here. Now I have a 3 right there instead of that 4. 5 times by 1 is 5. Plus that 3 is going to be 8. So I now have 80 minus 0 for my answer. So I've come to the end. So I should put 0.1875. But I'm not done yet because I need to remember that I took this whole number 4, so it needs to come back out in front of my decimal, and there I go. This is my answer for this problem right here. Now, as I look at this next one, I'm going to again start by taking this -3 and setting it off to the side and not worrying about it right now. I'm going to focus on this 4 over 9. So as I do this, I'm going to take this 4 and put it in the box and divide it by 9. So 9 does not go into 4. I add the decimal on bottom and up top. Add that 0. 9 does go into 40. It goes 4 times. So we can do 4 times by 9 is going to be 36. Subtract, and I'm going to end up with 4 right here. Add the 0, bring it back down, and I have 40 again. So I can see here that I have a 40 and I have a 40, which means that this is going to repeat itself over and over and over again. So I'm going to be done right here with this 0.4. So 0.4 with the line over the top, and then this is where I remember to bring in that -3. So it's -3, 0.4 repeating. So go ahead and try these on your own first. After you've done them, you can go ahead and resume the video and check to see that you got the same response that I did. Okay, so as we look at this, we need to first understand our study tip over here that if p and q are integers, then -p over q is going to be equal to -p over q, and it's going to be equal to p over -q. So as we look at this, what this is saying is when I have a negative sign outside of my fraction, I can either choose to move it into the top or I can choose to move it into the bottom, and it will still be equivalent. However, I cannot move it into both the top and the bottom, as that is going to change this fraction. So I have to choose one or the other. So as I look at this, I have my negative out front. For right now, what we're going to say is I'm going to take this negative and I'm going to ignore it, just like I was ignoring those other ones before. So I'm going to stick my negative outside, and now I'm just going to be concerning myself with my division. So I look at this, I have a 6 over 5, which means I'm going to be dividing 6 by 5. Always put the numerator inside of our little box and the denominator outside. So 5 does go into 6, it's going to go in 1 time. So 1 times by 5 is going to be 5 minus, and I'm going to end up with a 1 right here. Since I didn't end up with a 0, I need to add a decimal place here, add a 0, bring down that 0. Oh, gotta put my decimal up there. It's going to be 10. Now 5 does go into 10. It goes 2 times. So I'm going to say 5 times by 2 is going to be 10. And I'm going to subtract that and end up at 0. So now I'm done with my division. So I have 1.2, and I need to remember to bring this negative sign back in. So my answer is going to be -1.2. Now for problem number 2, again, I see this right here, and I'm going to set you aside just for a minute. We're going to say -7 goes wait over there. And then we are going to concern ourselves with the division of this fraction. Okay, so we're going to put 3 inside the box because it's in our numerator. Then we're going to put 8 outside that box. And 8 does not go evenly into 3, so we have to add our decimal places and add that 0. 8 does go into 30, it goes 3 times. So 3 times by 8 is going to be 24. So we subtract this, and 30 minus 24 is going to be 6. So I need to add that 0, bring it down. So as I look at this, I now have 8 going into 60, and I say that it's going to go 7 times. So 7 times by 8 is going to be 56. As I subtract that, I'm going to be left with 4, add another 0, bring that down, and 5 times by 8 is going to be 40, and we are going to end up with 0 right there. So I now have my 0.375, and I need to remember to bring that -7 back out in front, so I have a -7.375 for my answer here. Now as I look at number 3, I have negative 3 over 11. So again, I'm going to take this negative and I'm going to set it aside for right now. And I'm just going to focus in on my division. So as I look at this, I'm going to say 3 divided by 11. So 11 does not go evenly into 3, so I have to add my decimal places, add a 0. 11 does go into 30, it goes 2 times, that gives us 22. I'm going to subtract, that's going to give me 8. Add a 0, bring that down, that's going to be 80. 11 does go into 80 and it goes 7 times, so that's going to be 77. I'm going to subtract that and bring this down to 3. Add that 0, bring it down, and now I'm at 30. Now 11 is going to go into 30, and we have this already listed out right here, which means we have already seen that we're going to start repeating this combination right here. So I can write my answer as 0.27 with that bar over the top to indicate repeating. And this is where I'm going to bring that negative sign back into my problem, and my answer is going to be negative 0.27 repeating. And for my last problem here, again, I'm going to take this one and I'm going to set it aside for just a moment, and we're going to work on our division. So we're going to say 5 divided by 27. So since 27 does not go evenly into 5, we have to add our decimal places, add that 0. 27 does go into 50, it goes 1 time, so we can put a 27 right here. As we subtract, we're going to find out that 50 minus 27 is going to be 23. So we're going to add our 0 and we're going to bring that down, and we're going to add that right there. So now we have to know how many times that 27 is going to go into 230. So let's go ahead and try 8. 8 times by 7 is going to be 56. So we're going to put a 5 right here. 8 times by 2 is 16, plus 5 is going to be 21. So 21 right here, we're going to subtract, and 230 minus 216 is going to be 14. And again, we're going to add our 0 and bring that down, so 140. So now we need to figure out how many times 27 goes into 140. So let's go ahead and try 5 times. So 5 times by 7 is going to be 35. So let's put a 3 above that too. So 5 times by 2 is going to be 10, and 10 plus 3 is going to be 13. So I'm going to subtract these, and I'm going to have a 5. And then I'm going to add another 0 and bring this down, and then I'm going to add this 0 right here. Well, we should see some red flags right here, and we should say, oh wait, I started with a 50 right here, I just got to another 50 right here, so this pattern is going to repeat itself over and over and over again. So I'm going to just have this 0.185 with a bar over the top. And I'm going to go ahead and add this 1 back in front. So now I have 1.185 repeating for my answer. Okay, so for example number 2, we're going to begin writing decimals as fractions. So we're going to be looking over here at negative 0.26 and trying to write it as a fraction in simplest form. So the first thing that we are going to do is we're going to split this number into 2 pieces. Okay, we're going to be looking at the left side of our decimal place, and we're going to be looking at the right side of our decimal place. So for right now, we are going to go ahead and leave what is in front of our decimal place over here. So we're just going to put that negative sign right here. And then that piece that comes after our decimal sign, we're going to go ahead and draw a fraction line and put everything that came after that decimal place on top of that fraction line. So we're going to put 26 into our numerator. Now, for our denominator, we need to know our decimal places for our number. So since this is the tenths place and this is the hundredths place, we need to make sure that for our denominator we put 100. Okay, and that is because our decimal came out to the hundredths place. Now, a quick rule of thumb that we can use to remember how many zeros that we need behind this 1 right here in our denominator is to know how many numbers were in behind this decimal up top. So if we have 2 numbers up top, it goes out to the hundredths place, which means we need 2 zeros in our denominator. If it had 265. There's 3 numbers behind that decimal place. It came out to the thousandths place. That means we need 3 zeros behind that 1, which would be 1,000. So that's just a quick rule of thumb to remind ourselves of how to do that. Now, we would be done here if we did not have to put it into simplest form. So we do have to reduce this fraction of 26 over 100. So we need to figure out what factor goes into both 26 and into 100. So both of those are even numbers, so an even thing to do would be divide both the top and the bottom by 2. And by doing that, we are keeping the number the same. We're not changing our fraction. We're doing the same thing to the top and the bottom. So 26 divided by 2 is going to give us 13. And 100 divided by 2 is going to give us 50. Now, we do need to remember that front piece right here that we had, we need to bring this back and stick it out in front, and we have a negative 13/50ths as our answer. And we are going to be done because 13 and 50 share no other common factors, so it cannot be reduced any farther. Okay, so we're going to be writing a decimal as a fraction. We're now going to be working with negative 2.625, and we want to write this as a mixed number in simplest form. So again, we're going to be looking at the front piece of our number in front of that decimal sign, and we're going to be setting that aside for right now. So we're going to put negative 2 right here. Then we're going to be also looking behind our decimal point and this 625. Now this 625 is going to go on top of our fraction, so we're going to have 625. We're going to have our fraction line, and underneath our 625, we are going to have the number 1,000, and we have 3 zeros because it comes out to the thousandths place, or because there are also 3 numbers after that decimal. So that's why we need those 3 zeros on that denominator right there. So as we look at this, we do need to reduce this 625 because we want it to be in simplest form. So we need to find a number that divides evenly into 625 as well as 1,000. So we can divide both the top and the bottom by 25. So 625 divided by 25 is going to give us 25, and that's going to be over 40. Because 1,000 divided by 25 is 40. Now we can see here that both of these numbers are still divisible by 5, so we can go ahead and divide top and bottom by 5 again. And 25 divided by 5 is going to be equal to 5, and 40 divided by 5 is going to be equal to 8. So as we look at this, we have 5/8 over here, but we do again need to remember to bring in this negative 2, so our actual answer is going to be equal to negative 2 and 5/8. Okay, for this on your own, we're going to go ahead and turn these decimals into fractions in simplest form. So as we look at this, go ahead and pause the video here, and you can go ahead and try turning each of these decimals into fractions in simplest form. And then once you are done, go ahead and resume the video to make sure that we got the same answer and that you understand why I did what I did. So for problem number 5 here, we have negative 0.7. So again, the first thing we're going to do is we're going to set aside everything in front of that over here. So we got a negative right there. And in back, we're going to put 7 over here. And we're going to put it 7 over 10, and it is 10 because the 7 is in the tenths place. Now, when we're looking at this, we can say 7 and 10 do not share any common factors. They're not going to reduce any farther. So then we can just bring our negative sign back into this, and we are going to be done with negative 7/10. For problem number 6, we are going to be looking again at setting anything in front off to the side, but we don't have anything off in front, so we can just ignore that for right now. We're going to put that 0.125 into a fraction, so we're going to have 125 over 1,000, and it is over 1,000 because it came out to the thousandths place. Or we can look at this as 1, 2, 3 numbers, means I have to have 1, 2, 3 zeros in my denominator. Now, because both of these numbers are still divisible by common factors, we can divide both of these by 25. So 125 divided by 25 is going to be equal to 5. And then 1000 divided by 25 is going to be equal to 40. And now both of these again are divisible by 5. So I can divide 5 by 5, and I'm going to be equaling out to 1, and 40 divided by 5 is going to give me 8. So my answer here is going to be 1/8, because I don't have to bring anything back out in front here. I am all set. Then for problem number 7, I have negative 3.1. So again, I'm going to take this piece out front. I'm going to set it off to the side for right now. So that's a negative 3. I'm going to take that 0.1. I'm going to put the 1 over 10 because it is just going to the 10ths place. There's only one digit after the decimal place, which means I only need 1 0 in the denominator. Now, because 1 and 10 are as simplified as they get, we can just add that 1/10 to the back of our negative 3 here, and we are going to be done. And then for problem number 8, again, we're going to be taking that front piece right there and setting it off to the side for just a moment. And we're going to be taking that back 0.25 and writing out a fraction. So it'd be 25 over 100 because it comes out to the hundredths place. Or we can look at it as 2 spots after the decimal point gives us 2 zeros in our denominator. So we have this, and we have 25 over 100. We can reduce both of those by dividing by 25, dividing by 25. 25 divided by 25 is going to be 1, and 100 divided by 25 is going to be 4. So as we look at this right here, we have this 1/4 and we have this negative 10 set off to the side, so we can say negative 10 and 1/4 is going to be our answer. Okay, for example number 3 here, we are going to be ordering rational numbers. So the table shows the elevations of 4 sea creatures relative to sea level. Which of the sea creatures are deeper than the whale? Explain. So as we look at this right here, we have our anglerfish, which is going to be at negative 13/10 kilometers. We have our squid, which is going to be at negative 2 1/5 kilometers. Our shark, which is going to be at negative 2 11ths kilometers. And we have our whale, which is going to be at negative 0.8 kilometers. So an easy way to be able to compare numbers is to first convert them all into like terms. So the easiest way for me to do this is to convert them all into decimals. So that's what we're going to be doing here first. We're going to convert this anglerfish into a decimal. So we're going to say, okay, we have negative 13 over 10, so which means we can put 13 inside the box, divide that by 10. 10 goes into 13 one time, so it's 10 and minus 3, add the decimal, add the 0. Bring down that 0, it is now 30. 10 goes into 30 3 times, and that will now subtract out wonderfully. So my anglerfish is going to be at negative 1.3 because we had a negative out in front of our fraction, so I need to go ahead and graph that negative 1.3 onto my number line. And now I can go ahead and look at my squid. So as I look at this, I have that negative 2 out front, so I can just go ahead and set that aside for right now and just focus on the division of 1 divided by 5. So I put 1 inside the box, I put 5 on the outside. 5 does not go evenly into 1, so I add that 0.0, add the decimal right here. 5 does go into 10, it goes 2 times, so I'm going to subtract right here, and that is going to be just fine. So now I have this 0.2. I'm going to remember, oh yeah, I had this negative 2 over here, so I have negative 2.2 as my answer, and I'm going to go ahead and graph that negative 2.2 for my squid on my number line. Now for my shark, I'm going to go ahead and do the same thing. I'm going to go ahead and set this negative sign off to the side for right now and just focus in on my division. So I'm going to do 2 divided by 11. Now 11 does not go into 2, so we add the decimal point on bottom and on top, add that 0. 11 does go into 20, it goes 1 time. So we're going to go ahead and put in our 11 right here, and we're going to end up subtracting and getting 9. Adding another 0 and bringing that down, it's going to be 90. 11 goes into 90 8 times, so we're now going to have 8 times by 11 is 88. We're going to subtract this, and we're going to end up with 2 right here. Adding that 0, bringing it down, we have our 20 again. So we should notice here that we have our repeating pattern here, and we're going to end up with 0.18 repeating for our answer. So 0.18 repeating for our answer. And then we need to remember, oh yeah, we set this negative sign aside for just a minute, so we're going to have negative 0.18 repeating. So we're going to go ahead and put that onto our number line as well. For our last number here, it is already in its decimal spot, so we can go ahead and just graph that onto our number line. And putting that onto our number line, we now have all four of them ranked where they need to be, and we can now address the question of which of the sea creatures are deeper than the whale. So looking at our whale right here and looking how this is relative to the ocean, so the more negative that they get, the deeper they are swimming, we can see that our anglerfish and our squid is going to be deeper than the whale. Okay, go ahead and try this on your own real quick, and go ahead and then resume the video when you are done to make sure that your answer matches up with mine. So the elevation of a dolphin is negative 1/10 kilometer. Which of the sea creatures in example 3 are deeper than the dolphin? Explain. So we're going to go ahead and take this negative 1/10. We're going to do the same thing that we just did and go ahead and turn it into a decimal. So we're going to take this negative, set it off to the side real quick, and we're going to go ahead and have 1 divided by 10. Now 10 doesn't divide evenly into 1, so we're going to add our decimal here and here. Add that 0. 10 does go into 10, so we can now say that's going to be 0.1, subtract, and then we are done. So our decimal is going to be at 0.1. So now we need, we forgot our negative, so we need to put in our negative right here, so it's going to be at negative 0.1. So as we come down here, we need to graph that dot right onto our number line, and it's going to be right over here, because we have negative 0.2 right here, right on top of that shark one almost, and so negative 0.1 for our dolphin is going to be right here. So we have our dolphin. Now, to answer its question, which of the sea creatures in example 3 are deeper than the dolphin, that would be every single one of our sea creatures. The shark, the whale, the anglerfish, and the squid is going to be deeper than our dolphin. Okay, so as an extra example right here, we are going to go ahead and order these rational numbers, this negative 5/9, this negative 1 3/4, this negative 13/8, and this negative 0.6 from least to greatest. So we're going to start with this negative 5/9. We're going to go ahead and set that negative aside and just focus in on our division right now. So 5 divided by 9. 9 does not go evenly into 5, so we need to add in our decimal place. Add in that 0. 9 does go into 50. It goes 5 times. So as we look at this, 5 times by 9 is going to be 45. We're going to go ahead and do our subtraction. That's going to be 5 right here. Add that 0, bring it down. And this is when we should notice that there is a pattern already beginning to emerge. We have a 50 right here. We have a 50 right here. So this pattern is going to repeat itself over and over and over again. So we're going to have 0.5 repeating, and we just need to bring in our negative sign again. So we have negative 0.5 repeating for one of our terms. Now, the next thing we are going to be working with is this negative 1 3/4. So as we look at this negative 1 3/4, we're going to set that negative 1 off to the side and just focus in our division of 3 divided by 4. So 4 does not go into 3, so I need to add that 0.0, add my decimal up top as well. 4 does, in fact, go into 30, so we're going to add that as a 7. 7 times 4 is going to be 28. We're going to subtract this, so I have 2. Add that next 0, bring that down. That's going to be 20. 4 does go into 25 times. So 5 times by 4 is 20, and we end up with a 0. So we have this 0.75, and we're just going to tack that on to the back of that negative 1. So negative 1 3/4 is the same as negative 1.75. Then, as we move forward, we are going to deal with this negative 13/8. So as we work with this, we're going to focus in on our division and set off that negative sign right there. So we have 13 divided by 8. And as we look at this, we have the ability to divide 13 by 8. So we can do 1 right here. We do 8 right here. We can do 13 minus 8 is going to be 5. Need to add in a decimal place, add in that 0, and bring it down. So we can now say that 8 goes into 50 6 times. So we can do 50 or 48 right here, minus, and that's going to be 2. Bring down a 0 right here, and that's going to be 20. 8 goes into 20 2 times, that's going to be 16. So 20 minus 16 is going to be 4. Add another 0 and bring that down, and we're going to end up with 40, which means that I can now put a 5 right here because 8 times by 5 is 40, and it's going to bring my division to an end. So my answer right here, including this negative that we set off to the side, is going to be negative 1.625. And we are good, because now all we have left is our negative 0.6, so negative 0.6. And now we can look at all four of these numbers and determine what is their order from least to greatest. Now we need to remember on our number line that the least is going to be traditionally on the left, and the greatest is going to be traditionally on the right. Now, as we deal with this, we then can see, oh, here's 0. The bigger the negative number is, the least value it actually has. And the bigger the positive number is, the greatest value it's going to have, or the greater value it will have. So as we look at this, the biggest negative number that we have is this negative 1.75. It will be the farthest to the left, so it has the least value. Then the next biggest negative number that we have is our negative 1.625, which means it will be the next farthest to the left. And then we have our negative 0.5 repeating and our negative 0.6. Because 0.6 is bigger than 0.5 repeating, it is our next biggest negative number, which means it will be the next farthest to the left. And our last one right here, we have our negative 0.5 repeating, which is our least negative, our smallest negative number, which means that it is going to be our greatest value here. So our order is going to be our negative 1.75 followed by our negative 1.625 followed by our negative 0.6 and finally followed by our negative 0.5 repeating. So this is the order that we will be going in for our answer here from least to greatest. And here we are at our mini assessment. So go ahead and work on this mini assessment. Go ahead and find as many correct answers as you can, and I will be checking for this on Friday in our binder check. So go ahead and write each rational number as a decimal. And for problem number 5, when your cousin was born, she was 21 4/5 inches long. When your friend was born, he was 21 5/6 inches long. Who was longer at birth?